The Cobra extinguishing concept, CEC, is the safe and most efficient way to take control and minimize risks at compartment firefighting. The method is based upon 3 combined tactical parts. Scan the outside of the building with thermal imaging camera. Rapidly cool down the hot fire gases with the Cobra. And ventilate with PPV. Altogether, this creates tactical advantages and much safer environment for fire personnel entering the building. The efficiency of the Cobra is superior to any other application of water due to the very high pressure which creates a very fine water mist ejected at very high speed. The system delivers 60 liters per minute at 300 bars, and the result is a very fast suppression effect on the fire, no water damages, and safe operations for the firefighter. Cobra is easily operated by one person and can be fitted to any kind of fire vehicles. By its unique capability to quickly pierce through any type of material and fight an inside fire from an external and safe position, the Cobra dramatically increases the firefighter's safety and efficiency. The multi-purpose nozzle Mpn complements the cold cut Cobra when responding to many types of operations. The addition of the Mpn broadens the use of the Cobra and in combination provides an enhanced ability to manage many different firefighting scenarios more effectively and efficiently, such as car fires, outdoor and indoor fires, dampening down operations, decontamination, and foam attack. The nozzle is connected with a few simple operations and delivers the same amount of water, but at a lower pump pressure. The Mpn uses the very same hose as the Cobra, typically 80 meters long, which minimizes weight and space required on a vehicle, but still provides a range of operations sufficient for most incidents. Radio control, as normally used with the Cobra, is not required when working with the Mpn as it operates hydraulically directly from the branch. Mpn is a nozzle which operates by the use of a two-handed pistol grip which can provide variable spray patterns. The spray is easily adjusted from a narrow to a wide cone and even a flushing mode. The pressure at the nozzle varies between 15 and 60 bar, depending on the setting chosen by the operator. The Mpn also has a foam expander which can be used for car and pool fires. Mpn can be fitted on most types of new cold cut Cobra applications and on small vehicles. The extended capacity is a great advantage, wide area of usage and good return on investment. The combined system of Cobra together with Mpn will provide a wide range of usage, one system with multiple applications, and can respond to everything from a bin fire to a high-rise incident or even big industrial fires with large volumes. Traditional or conventional firefighting often includes committing breathing apparatus crews into the fire compartment. The fire compartment can often be several hundred degrees and visibility very low. This tactics expose the firefighters to risks for backdraft or flashover situations and collapsing structures. Current research also show that the long-term effects for the exposure can greatly increase the risks of certain types of cancer. This tactics and other traditional tactics, such as fighting the fire from the outside through windows, etc., also means that the fire is ventilated, which can rapidly change the dynamics of the fire and the risk of flashover is increased. Typically, the water usage and/or foam additives in traditional tactics is very high, creating both severe water and environmental damages due to the dirty runoff water and toxins. The Cobra cutting extinguishing method enables firefighting effectively from the outside without ventilating the fire. By such, it is a unique methodology for its effectiveness, external firefighting and offensive tactics. Many fire services initiate the intervention with the incident commander scanning the building from the outside with a thermal camera in order to determine where the hotspots are and where the Cobra will make the best effect. Within seconds, the firefighter can start the intervention with a Cobra from a safe position. The Cobra is rapidly deployed due to the lightweight hose which is 80 meters as standard, enough for most interventions but can be extended up to 200 meters. The Cobra lance operates with a very high pressure, 300 bars, and with an abrasive which is induced, the lance will cut through any building material, and most often the water will reach the fire within seconds. Critical aspects in this phase are that the hot fire gases are rapidly cooled to a safe level, without the need for ventilating the fire or committing the firefighters into the compartment. Due to the very small water droplets and the high speed of the water, the temperatures of the hot gases are rapidly reduced. The smaller the droplets and the higher the speed, the better the effect will be. As the water evaporates so quickly into steam, the inerting effect can be significant even in situations where the fire is ventilated. Once the fire gases are cooled, many fire services continue the intervention by ventilating out the fire gases that are now relatively cool. This is done by opening ventilation in the opposite side of the compartment while applying a PPV from the other side. In many situations, the Cobra attack is sufficient and the fire is extinguished. In other situations, a BA crew may be committed to the compartment depending on circumstances. It is important to understand that the Cobra attack can be done during the time the BA crew prepares its operation, and that the Cobra, by greatly reducing the hot temperatures, will make the BA operations much safer and faster. The Cobra shall hence not be seen as a complete alternative, but as a complement to traditional firefighting. When the BA operations are committed, they will be able to work in a relatively cool environment with lower risk and much better visibility. Often a very limited usage of water is needed for the compartment firefighting following a Cobra attack. SP Technical Research Institute of Sweden has done considerable research on the Cobra. Most significantly, the drops are extremely small compared to any other systems in the marketplace. This means that the total surface area is very high from the Cobra, and hence the efficiency of the cooling effect. When comparing the Cobra drops to drops from high-pressure nozzles or fog nails, the distribution of droplets is 0.1 mm for the Cobra and almost 1 mm for the other systems. The water droplet size is one of three critical components of the efficiency and is generated by the very high pressure. This illustration demonstrates the relative difference between the Cobra water mist and the relatively big drops generated by fog nails or high-pressure nozzles. The two additional components are the speed of the water jet and the water volume, which determine the maximum suppression capacity. As a comparison, the total surface area of the water from a standard 8-bar firefighting nozzle will cover a normal soccer goal, while the same amount of water from a so-called high-pressure nozzle of 40 bars will produce a total of half the penalty area. This includes the fog nails that are being used in some markets. Note that if the surface area is small and the droplets are big, most water applied will have no effect on suppressing the fire, but instead only create water and environmental damages. Big drops fall to the floor 10 times faster and will not evaporate, while the Cobra water mist hangs in the air until evaporated in the hot gas. Ultra-high pressure systems going up to 100 bars produce smaller droplets, but still the surface will only cover a third of a soccer field with the same amount of water. The Cobra, as a comparison, will generate a total surface area of the whole soccer field. The following graph displays the heat absorption comparison between the Cobra and other systems. The graph demonstrates that the Cobra efficiency is 5 times higher than the other tested systems, only due to the droplet size. When considering the much higher speed, the effect is several times higher. The heat absorption efficiency confirms the common empirical view that only 5 to 10% of the water of conventional firefighting is effective, while 90 to 95% of the water from the Cobra actually suppresses the fire. As a final demonstration, the pressure of 300 bars also generate a very high velocity of the jet. The research demonstrate that the Cobra jet has a speed of 200 meters per second at the nozzle. But even after 15 meters, the Cobra jet will have a speed of 5 meters per second. This means that the reach of the jet and suppression is very long, up to 60 meters in compartments according to experienced incident commanders. But also that the Cobra jet will generate turbulence, hence reaching all the hot gases in the compartment. As a comparison, 40 bar systems will only have a droplet speed of about 1 meters per second, 2 meters from the nozzle. Modern firefighting requires additional methods and tools. The patented Cobra has now demonstrated its capacity in thousands of incidents in various countries and situations. The Cobra gives the incident commander new methods in the toolbox and a capability to quickly control situations that can otherwise become dangerous. The Cobra concept is often embedded fully into fire services as a complement to conventional firefighting, while some services benefit from the organizational opportunities with the Cobra as a rapid response concept. Join us for a world of safe, clean and efficient firefighting.